Nima and I spoke the other day, and I think we got into this like rabbit hole of Codegen and what is adding value and what is not adding value. And I was really, really excited about Durable's approach to Codegen, because I think that we're now, as an industry, coming to terms with the fact that code and workflow are very different things, and the underlying compute, right, and the underlying symbols are very different from just plain text code. And so, to give people a little bit of context, I would love to understand your journey and what is Durable, if we can start with that. What is Neuro-Symbolic AI?
Yeah, thank you for having me, Antonio and Upal. Durable, at its core, is a platform to enable anyone, regardless of their ability to code, to build their own custom software applications, automations, and tools, and then go beyond the building of it, maintain them, modify them, and the full life cycle of that. So really trying to raise abstraction of software building above code and bring it over to natural language, to human interfaces.
That is awesome. And you guys mentioned the concept of Neuro-Symbolic AI a lot, and I was really excited to dive into that because I feel it's very different, even when you think about semantics. What is Neuro-Symbolic AI?
It's not a very fixed concept, but at its core, it's that you have deep learning models side by side with symbolic AI techniques. In our case, that means search and symbolic verification. But the two are working together where they excel to bring some AI capability to the product. So we really think about, if you think about the layers, the problem we're solving, then the specific product vision we have in mind.
Yeah.
And Neuro-Symbolic AI is just our bet on how to make that product vision happen from a technical perspective. We'll use whatever works, basically. The bet has been for a couple of years now that some of the symbolic techniques that we're using, like search, logical search, like type inference, these seem really hard to get rid of. Like they add a lot of value to what the AI capability is at the end. And then we use a lot of different deep learning techniques, be it our own custom fine-tuned models or LLM calls that we make. So it's all part of a larger system that's really focused on what the product needs.
Would it be correct to say, because I feel how is it different from the traditional? Well, I guess it's not as traditional, right? Because it's fairly recent, but how is it different from the usual code-gen technique of using let's call it an LLM just outright to generate code?
In our case, our output is not in the space of syntax as you would be in an LLM. So in an LLM you'd be outputting tokens in some programming language syntax. Our inference engine outputs its steps in the space of actions that compound together. Yeah, each action is you can think of it as an API call, a function call that compound together to meet the end effect, side effects, and direct effects that the user want. I think we're really strongly influenced there by robotic motion planning, which in effect is if you want to do something with a robot, your actions are motor actions, move this motor basically.
Sure.
And your AI needs to understand the consequences of these actions, each individually, but also how they compose, and make sure that they compose in a way that meets the highest level objective, which is usually what the user wants. So typically you plan backwards from that, because planning forwards is really difficult to sort of aim it. So you plan backwards from what the ultimate objective is, and it's basically backwards compounding actions.
Interesting.
And to me, that's a very different paradigm than outputting basically character by character what the syntax is. So every time what we're building outputs a single step, that single step is an action. And that action can be very high level of abstraction depending on what API we're using. It could be a very high level API call.
Cool. And I guess just to kind of refine, like, our understanding a little bit. So would like the artifacts of this kind of process be like, there's one kind of overall kind of hierarchical kind of like function that actually achieves that like end objective. And then these actions are breaking into, let's say, steps of like pure functions, like in like more of a functional programming sense of like kind of interleave to like result in like that desired like outcome.
You got it. Yeah. Basically it's that you start with the user, whatever the user wants. And this can be, I mean, it could be a page-long description of all those other things.
Totally.
And we basically have to break that up into parts and subparts and subparts. Unfortunately, human language has a lot of flexibility. Like you can say things that have global reach. It's not just do this, it's do this. Oh, and then every time you do it this way, I want this to be true. And that can be really difficult because you have to propagate that everywhere, that little constraint that the user mentioned.
Exception handling in language.
Exactly. Yeah. But basically as a high level concept, it's as you said, we break it up into components and subcomponents and subcomponents, and each one has to get resolved with actions that we know how to take, but maybe more critically know what the consequences of are. And so there's some really interesting things happen. Like you can get to a point where you're like, we've broken this down and we're trying to make this happen, and we just have no way of doing this. Like either we don't support the API, we don't have the knowledge, there's no way for us to do this. We can go back to the user and have that back and forth. So I think you end up in a different paradigm. You're actively asking questions because of this. You know that there's some missing input somewhere way down this decomposition process. And that question can be, hey, I'm missing some input, or it could be, I'm actually missing some knowledge here. I don't know how to do this. Can you break this down into steps for me? Can you teach me how to do this? Or maybe there's just an API that I'm completely missing. So that's kind of a terminal point at that stage.
Well, that's so fascinating. So I guess you're kind of sandwiched in the middle between the underlying functions, which I think that perhaps in a different way you could explain it as these atomic units, right? Like the atomic unit you would generate in a normal, let's call it LLM, is purely just tokens, right? And it's basically unstructured code, as opposed to the probably the most atomic unit you guys generate is the step or the action.
Yes.
And then you can chain these actions to execute a series of logical steps that reach to the end goal. And that's kind of the compute layer. And then you have the human layer, which is the user is trying to explain to you what they want accomplished. And something that I really liked, you gave me a demo a few weeks ago, and something that I found extremely intelligent is that the surface area for the user to communicate with the underlying, let's call it AI, as AI is a global term, is not a chatbot, but a PRD.
Yeah.
Right? It's a canvas where the user dictates the functionality as a series of, you could write it as user stories, you could write it as like a more traditional PRD. And I thought that was really interesting because that is the way that in a productionizable setting, people communicate knowledge with one another via PRDs, via functional requirements, as opposed to a chatbot, right?
Yeah, there's so many features about a document that make it really good for this. Maybe starting with the mechanics, it's multi-threaded. Right? Chat is single-threaded, or as a document, you can have many different areas. And the way we think about it is you comment on the document. We're on well-trodden ground here. This is how PRDs work. You would comment on it, and someone else would, look at that comment, make an update, comment back. This is a really kind of nice interface for multi-threaded discussions. But then there's this concrete constitution as a result of it, which is this document. This document tells you, what am I building? How's it going to work? What are the exceptions? Maybe here are some, test cases. Like in this scenario, it's going to do that. This is how we think of this document. But I think when the document is describing application, an interesting perspective to look at is levels of abstraction. The user is going to be at this level of abstraction, very high. As an example, one of the apps that we were working on for ourselves was one that makes introductions between two people. This is something I needed because I was just making a lot of them. And I was like, I just want something that goes and finds LinkedIn information on one person,
Yeah,
the other
sure.
person writes a little blurb, and then then checks with each person, hey, do you want to be introduced to this other person? Reads the answer, and then I'm involved in the process. I'm getting notifications that this has moved on, this has happened, and then I can sort of approve every step of the way. So the way I would describe that is up here. There's some API calls that are happening. They're all the way down here, like Gmail API calls and whatever. And there's a series of abstraction levels between them. And the document is actually a great way of unraveling that to the user. So if you want to stay really high level, you're reading the section headings that say, like, in this section, we're going to get confirmation from each person about whether they want to be introduced to the other person.
Yeah.
But then you might want to know, okay, how is that being done? So I'm going into a subsection, or if I'm getting confirmation, I'm sending an email saying, hey, I would like you to introduce you to so-and-so. Is this okay? Okay, that's great. How are we doing that? I mean, you can go all the way down, and the limit is the action, which is to send an email. I'm using this Gmail API. And like, that's the limit. That's sort of the event horizon beyond which the user cannot see, because that's also where the AI capability is taking its atomic, as you said, action. So documents are a great way because you can present all of this and allow the users to kind of introspect as deep as they go, and they can comment at the abstraction level they want. If they want to stay really high level, they can comment really high level, and we can then propagate that down through the planning process to whatever abstraction level we need to make the change.
That's such a smart input method, because I feel like one of the issues that I've seen with chat, obviously it's single threaded, you're totally right. The other problem is that it's ephemeral in nature. It's not meant to be saved or stored or persisted, as opposed to documents, which for the most part, you're meant to actually store because you're using them as a fixed, or as a let's call it, as a board that you can send to a colleague, for example.
Yeah, and this makes me think of like the analogy of like, like how so many teams end up relying on like Slack as like a source of truth, and then realizing how brittle it is, and then having to move to like documents and whatnot. And it's funny to kind of see these analogs, even just within interfaces that we are like building there. Yeah.
Yeah. Nima, to give you a little bit of context, I feel like something that happened at Silo years ago with our product team. I mean, we were a total like 4 or 5 product managers. We would change requirements sometimes in Slack threads, right? There would be a question to user story. You do a little bit of back and forth, and then you almost needed the discipline and fortitude to go back to the Notion doc and change it to reflect the latest changes.
Right.
So we tried, that happened a few times, and we tried never to do that because, well, chat disappears, right? Just because Slack says it's stored doesn't mean that you can actually access it meaningfully.
Yeah, even humans communicate single thread like that.
Yeah, that's a great point. And I think what we wanted, and maybe what would have been helpful for you, is if some other entity like the AI is actually updating that doc. And in this case, document is kind of the source of truth.
Exactly.
You can comment on it. The AI actually, in our case, the AI actually writes the first draft from like your unstructured initial requirements, and then from then onwards, it's really charged with updating it. So if you comment on it and you say like this should be some other thing, it's gonna go off and try to make that happen. It could come back with, I did it, no further questions required, or I did it and here are some other downstream questions that came up, or I just couldn't do it. Like, the thing you said was not possible or conflicted with something else, and here's a dialogue we can have. But that dialogue is very localized. So when we ask questions of users, we're like highlighting a section in this PRD that corresponds to somewhere in that graph of decomposition that we needed either input or something missing or something conflicting.
That is so smart.
So there's kind of this one-to-one mapping between the what I think of it as a projection or rendering of that graph to the text of the document.
It is a knowledge graph after all. You're totally right. Nima and I actually met in person like over 10 years ago for the first time when I was working on Kite, and we were reminiscing about the Kite office being this ginormous floor in one front street with like, you could probably have 55 people working comfortably there, and we were 4 or 5 people. And so it was just like, I remember Nima described it best. I think you said something like, you just go in and it's an entire empty office, and then 5 desks like gathered in the center. What has happened since then? What got you to this place? I mean, I know you worked on Canvas and then Amazon. What is the story that got you to Durable?
Yeah. And by the way, just a note on that story,
Yeah.
I was still working on my PhD in a PhD labs.
Yeah.
They can have constrained funding, things are scrappy. And I walk into this massive office. It was really like the Silicon Valley moment for me.
It was the most irresponsible spend you could ever think of in a
well,
startup.
I'm not making a judgment on that, but it was just for me really impactful to see like, wow, there's so many more resources here.
That is true.
So yeah, that PhD led to Canvas. I was lucky enough to meet my wonderful co-founders by random chance somewhat. I hadn't even finished. Then we did Canvas, which was the real IP there was what I think of as an embodied physical agent. That's really, I mean, we were a full stack robotics company. We were building this thing from the ground, like really from the wheels up. And that's hard to do. But I think the part that for us was the most unknown was how to build this physical agent that had a very long, and I'll use the term coherence time span, because we couldn't be intervening with this thing all the time. We had multiple of them in fleet deployments, in warehouses and manufacturing facilities. And the really the key measure we had was how long could they be coherent without us stepping in.
That's so interesting.
And so that lent to, I think, a lot of influence for Durable. Durable came out of my frustration at the abstraction level of software, and observing this abstraction increase from punch cards to low-level programming languages to high-level programming languages. And then there's a wall that we hit where a lot of the high-level languages are basically the same. And it's because they're formalisms. And if you want to make this step over to informal languages, there's the informal to formalism gap, which that opens up planning and a lot of like near AI capabilities that are required. So that was my frustration. And I was looking Durable. This is in 2021. Is looking for a way to make this happen, both from a product perspective and a technology perspective.
Yeah.
And my co-founder is someone I worked with in the lab, and then as part of Canvas, we have some other Canvas folks on the crew as well. So there's a lot of influence from that company. Launched the company in 2022, early, mid 2022. I mean, that was the year that ChatGPT came out. So there was like a lot of change happened after we launched it, but I think we made a bet that from a product and tech perspective that is still relevant, and we've been building that ever since. Yeah,
that's wonderful. I mean, I think that I think Upal and I have talked so much about it as well that like I feel like we got a little stuck in terms of abstraction layers. Like what you were saying makes total sense, right? We started with punch cards as a means to communicate with some compute underlying process. And when I say compute, you could have a computer that is completely mechanical, right? Like, and we've slowly added more and more layers of abstraction. And two things have happened at the same time. One is in environments where these abstractions are a little bit more loose, like front-end engineering, we've ended up, as myself a front-end engineer, I realize now that building a JavaScript like application today is just a complete bloat of libraries and dependencies within dependencies. We've created, the reason why we need Dependabot is that we've created this problem ourselves. Like we are owners of this failure.
Hey, I don't know how to write padding, so I need left pad.
Exactly. The left pad situation is one of them.
Out of space.
That's one thing. The other one is what you just described, which is that a lot of the newer languages all look very similar because we've hit kind of a ceiling when it comes to what else can we formalize. And I think that I think what we rave about, and look, I won't shit on them as much as I used to, because I think that Cursor in particular has proven that they can add some value. Now, whether that value applies to productionized environments where you need a little bit more validation and testing, that's left to see. But we were actually just talking yesterday to the VP of engineering at Silo, and they use Cursor, right? And I think that the conclusion is software has a little bit of a easier texture than it did, let's say 5 or 10 years ago. In my mind, though, the problem still stands, which is what you were describing, which is what is that interface between informalism and formalism? And is that interface just a text compression engine, which is what really, at the end, you're just compressing and decompressing knowledge, right? Or is there something that is a little bit higher order that orchestrates these as functions or as compute units? And that's why I'm so excited about Durable, because it's a little bit of a higher order intelligence on top of just pure text, right? And one of my biggest complaints is that, look, LLMs are notoriously terrible at repetition. They get trapped in loops very, very easily. And in GitHub, when you use GitHub Pilot, for example, I run into these every single week where if you have a switch case structure, something as simple as a switch case structure, there's no broader semantics there. It just thinks if you keep just auto-tabbing and auto-completing, you're going to end up with an if statement of like 15 different conditions.
It's like the ontology of your control flow. You can throw anything in a switch statement, right?
And so I'm really excited about Durable because I think that it is an opportunity at building a new texture for that informalism to formalism, right? That eternal dream of no code. I still remember when no code started and retool. So it's like, well, are you building true abstractions, or are you just trying to find a better interface for that lack of communication between informal and the informal,
Yeah, no code, its history dates back to the 80s and 90s. It was called visual programming. And I think it's this long history of wanting to raise the abstraction level. And with no code, I think is a little bit of a trap in that you're really programming, but with blocks.
Yes.
But you do have, and the difference I think there is that it's an imperative mode where you're saying do this, then do this, then do this. Yeah. And implicit in it, there's a latent what I want at the end, the outcome.
Yeah.
And you don't ever get to just say, I want that outcome. Your abstraction level is too high. And so you're programming. So I think that's right. But how you get to that, I think it's a really interesting bifurcation, because there's one, let's call it the dominant narrative, is that we will get better at syntax level generation.
Yeah.
And then we'll just keep doing that, and the error rate will go down, and eventually the error rate will get to 0. And if it gets to 0, well, now you have the ability to generate software. What's still missing is all the interfaces that we talked about before, which is if you zoom out, there are actually different roles in the software development lifecycle. You have a product manager, you have a developer, and you have DevOps, and these are 3 different roles. And next token prediction is really the developer role, but the product manager is negotiating feasibility versus requirements. Sure. The DevOps is actually managing the life cycle, deployment, error handling, the insight of what's happening, why did this happen, why did this not happen. So even if you get the developer, let's say, to 100%, you would be missing these other roles, and there's some question marks there. But let's say that's a horizontal approach. Like, we're just going to get really good at horizontal software generation, and then at some point we'll fix all these problems. Our bet has been that we'll build the product for the whole software development lifecycle. So you have the product manager role, which is our document, the AI going back and forth. The developer is obviously the action-based inference engine, and then we haven't talked about the deployment perspective, deployment part of it. But there's a whole part of our product which is, okay, I want to deploy this. Now I want insight into what's happening. I want a certain amount of supervision so I can stop it before it does something I don't want. And I want to modify it as I go forward. So we thought, let's build a product that does all of that, but not for every possible app, for every anything that you could want. And then we grow the scope. Yeah. So we have a full system that can do it for non-coders, and then we grow the scope, and then we add more APIs, we add more, let's say, graphical interfaces, stuff like that. I think these are 2 really distinct approaches to this. They have different modalities. I've spent a lot of time thinking about it. Obviously, we've made the bet on one end of it, but I would say most of the money and the hype and the attention is on the other end of basically scaling token generation. Today we're having this conversation after the release of O3, And some amazing results are coming out of scaling token generation, which will make that code generation better.
Yeah.
So, but there are still the missing pieces of how do you bring it together with product management and DevOps and the entire software lifecycle to create something that is not just creating code, but creating software, meaning code that's correct and runs, and lets me modify it and lets me gain insight into its execution and so on. There's so much that goes into live software versus some code that you have.
Because you guys have focused not just on the content, on the pure content, on the pure code, but also on the life cycle. And I think it's really interesting that you guys decided to also do deployment. I feel that depending on the persona you're targeting, you have to, right? Because I don't know if you guys are targeting how technical the user is, but I'm wondering if like the final outcome of Durable is like, here's a bunch of code, just do your thing. Here's a GitHub repo, go do. It may not be possible for the persona that you're targeting to just deploy it themselves.
Not at all. Our assumption is always, I mean, even developers struggle with deployment. Deployment is no joke. So I think our assumption has always been that we want to deliver the full life cycle, which means that your development has to have deployment in mind. Yes. You know, when you're using your actions that you're compounding, you need to know that I can take this action because I'm authenticated with this API. And so the user needs a way to connect that API. This is kind of similar to no-code territory where, you know, if you have Zapier, it would hook up your various APIs. But then the code, the inference engine that's creating the actions, it knows this. So it knows that I can take these actions. I can have access to these API calls. And so when we create the software at the end, we have some guarantees that it type checks, that it has runtime constraints that we know are true, and that we can actually deploy this. And so we do. We spin up a Docker image, and we know that it'll run, and it'll hooks up to a whole bunch of like monitoring endpoints that we've put into it so that we can answer the follow-on questions that the user is going to have. What is it doing? Why did it do this? Why did it not do this? Et cetera, et cetera. I mean, because otherwise all of these require development experience to go in and set debug break. I mean, what are you doing at that point? You're looking at log files. Then it's a very technical audience. And I think that is then the other bet, which is let's just make development tools better until they lead to the full development life cycle being automated.
Yeah, just to kind of build off of that, just given, you know, how just critical, you know, you and your team are kind of highlighting like the trust, especially a part of like that typical kind of DevOps life cycle. Like how do you all view like, you know, CI/CD and like these edits and testing that inevitably happen? Like, you know, something extremely common in software like development, especially in startups, is like, you know, you make hypotheses and assumptions in a PRD, and it, you know, honestly, it doesn't matter how correct the software is on the output. Like it was just based on like faulty assumptions or like maybe the wrong test cases and whatnot. So how do you guys think of that through like that more extended life cycle? Since, you know, I can read between the lines like a little bit, but like as you kind of laid it out, it's like it's already very well formatted for, you know, there's a very clear outcome and goal to drive. There's just ambiguity in the implementation, but like, you know, how do you guys think of that, correcting that, and like also that kind of iterative development process beyond that?
Yeah, I'll create 3 buckets here. The first bucket is the specification setting.
Sure.
Like, okay, I want to communicate what I want, and I want to know that has been understood. The second bucket is implementation. Like I've communicated what I want, but I want to know that it was implemented correctly. And the third bucket is runtime. Like we've done all of that. Now it's running. The inputs are whatever they are, right? Like things could change during runtime. So for the specification bucket, we think about in 2 terms, understanding and control. Understanding meaning the document, the varying levels of abstraction. I can look at the document and I can understand that my input has been understood. And I can understand how it's been implemented. Control is that I can highlight something, I can ask for a change, and then I see how that change is implemented. So now this helps make certain that I have been understood. At that point, you're looking at implementation. So now that it's been implemented, the document tells you like, okay, I'm going to intro the the users in this way, to go back to our email intro. But what we haven't quite done this, but our aim has always been to elevate the various testing regimes like unit tests, integration tests, to the level of abstraction where the user understands them. So say, hey, so if I'm making an intro between Mary and Joseph, here's how I would do it. Here's an example email. And then you would look at that and be like, actually, this is wrong. And that would take you back to the document to iterate. And then the final bucket is runtime. So all of this is said and done. I still don't want you to send out emails before I can see what's being sent. So we actually do have this layer of supervision in the web app where you can block the execution. And this is why, by the way, deployment has to be managed by us. So we can basically put all of these into the software we generate, and we say, okay, don't actually take this action. We have a link between that action back all the way to the PRD. So we know what the action is for. Yeah. Because the user said, okay, I don't want you to take this action, or we automatically blocked it. And the user gets a message saying, hey, I'm about to send this email to these 3 people. And you have a point at that point where you say, oh, this looks great. All right, don't ask me again. Or whoa. Yeah. Let's go back to the PRD and figure out how do we end up like making this happen. So again, there's layers, obviously with the if you're trying to be general purpose, there is no formal verification possible of, let's say, an email introduction app. But we can add these layers that over time build trust, and you can imagine a user will never initially have trust anyway. So they'll want to supervise all the actions, especially the irreversible actions like communication, moving records around, deleting things. Until they build trust.
Yeah, totally. And I think that, really aligns well with, I think, kind of how we view like a similar space of problems that we operate with, where it's just like, you start with an understandably lower trust environment with the user, given, there are these, let's say, stochastic components happening under the hood, but then you expose the tools for them to build their own trust with the system. Like, they are guiding and handling it. They have that pure observability of like, these are the steps of actions. Here are the APIs, like, actually like tied in. Here's how it actually, when you zoom out, kind of lines up with the overall requirements. When you zoom back, like in, as you mentioned, the logs and the observability about the steps and the actions, especially the kind of the awareness that's highlighting. And I think that's like, really, really kind of strong design there.
Oh, thanks. Yeah. And going back to the technology, a lot of the technical choices have been, are with this in mind. So we want to be able to link every code action to something that either the user wanted or was a decomposition of what the user wanted. So we can say, like, we're doing this because of all of these. This is going in a little bit into our roadmap, but I think chat actually comes back as being a really interesting interface here. Like, once you have the document, once you have all this insight, chat becomes really nice, because you could just freeform be like, so how are you verifying these users? We can point to the document, be like, it's all here. We're just open it up for you. Here's the steps we're doing. Or at runtime, why did you send this to that person? All right, we sent it because it's this step of how we implemented, let's say, this part of the requirement. And this actually happens in any software development lifecycle. It's just people are doing it. Like the owner will go to the DevOps person and be like, why did this happen? And the DevOps is like, I'm gonna talk to the developer. They'll know. And then there's a bit of negotiation of having but this is actually really hard to do if you don't write the software such that it can be introspected into.
Exactly. It's like this, like, kind of like holistic stack trace, like, out of that.
Yeah. Stack trace is like a human understandable stack trace that links back to the high level abstraction requirements of the user that they saw as part of like the how are we going to implement this.
Yeah, and chatbots there can be a very powerful communication tool, provided there is a source of truth. And in your case, that source of truth is the PRD.
Yes, exactly. And the PRD is really the anchor that anchors the runtime information, because it's all mapped against the PRD, and the graph that is really mapped against the graph that is behind the PRD. But you're absolutely right. So, the way we've thought about these chat systems is that there's kind of a retrieval, like RAG-based system, where you are retrieving against this source of truth, and you have a projection into language that the user can understand, but you're really anchored on the stuff that we've built the app using.
That's so interesting. I think this is a good segue into us talking a little bit more about coherence time span. Because when we were emailing back and forth, you had written recently about this, and it's funny because Upal and I were talking about this right before the podcast, where that is actually so relevant to us as well, and I feel like it's going to become more and more relevant as people build more complex applications on top of stochastic abstractions. And I feel like we're starting to get whiffs of that with the idea that there is a source of truth involved as a means to carry over context. But I was really curious, from your perspective, on how you feel. What is coherence time span?
Yeah, I mean, the way I think about it is very rooted in my robotics background. But it's basically like, if you understand the outcomes that you want to achieve, how long can you stay coherent in your actions in pursuit of these objectives? Humans have decades-long coherence time spans. If your dream is to get in the NBA, I mean, you have a decades-long journey where you have setbacks. Setback meaning like your predictive model was unable to predict what happens in reality. So you planned for something, you had a setback, and you're regrouping all of your actions, all of your learning is being factored in, and you're coherent over years. I think what we're finding is that, let's say next token prediction, your coherence at the moment time span is in, like hour, 2 hour. And that's just really token generation. I think when there is actually a benchmark for like agent planning, and I want to make sure I reference it correctly, but I think it was in the order of like between 40 to 70 functions can be composed before coherence is lost. So we're talking like really small numbers here. And it's an open question. Like, we have O3 coming out today. These models are amazing. Why is coherence time span so short? Why we care about this is because our agents they're actually planning for future execution. So you're kind of one level removed from the thing that's actually executing. But regardless, the agent has to write software that stays coherent for a long time, and the agent itself has to stay coherent for the duration of creating that software. And so we think about coherence a lot. And I think that the interesting question here is, why is it difficult? Why is it so hard to stay coherent? What's special about humans that lets them be coherent for years?
Yeah, and I think like I would love to kind of dig into kind of your thoughts around like, like I think a lot of folks like, I feel like this concept is just only starting to kind of hit the zeitgeist, given like, all these claims have been made about agents in particular. They're getting deployed into production, and this is going to be a pretty huge generalization. And honestly, like, this is actually kind of based off of a lot of like evals and results I've read among like, even I know like Sierra, the customer support startup, wrote like a paper and an eval benchmark around this, where it's like these things like the failure modes and like this kind of like half-life like happens very quickly. It's like they cut off like on actual like capabilities and whatnot very quickly. Like, and now like people are trying to be like, oh, let's go back to RAG, and like this is just, we have to reduce this into a search problem. That is the whole thing to kind of solve there. But like it's not that I feel like people have already developed these agentic systems like that. So that clearly isn't, there's no silver bullets, and that's clearly even less of a silver bullet than being described. So like, especially kind of pulling from your robotics background and having to kind of have these kinds of systems like have this level of coherence in like the real world, like what are, it could be as speculative or theoretical as you think of, but like, what are the missing links like there?
Yeah, if I think about robots staying coherent in the long term, I think there's two ingredients that is necessary. One is a world model that is like correctly predictive, so that you can know what happens if you take an action. I mean, if your predictions are wrong, you lose coherence because you're planning, let's say, over a long enough time horizon. So you need to know what's out there, what the world looks like, and also what is the consequences of my action. So there's a causal aspect to it. But then you also need to be able to plan ahead long enough such that the error that you incur during replanning doesn't grow unbounded once you take an action. So if I plan, let's say, 5 actions ahead, I take one action during that plan and then I replan. Let's say that's the loop. If I was so wrong about the 5-action horizon that I take my first action and I just totally did the wrong thing, I lose coherence.
Yeah.
I just can't get to where I thought I would get in my 5 actions. That in robotics, what does that mean? The world model is physics. I mean, you're just writing basically, usually it's like physics engines. Physics engines they have kind of bounded error. And then you have motion planning, and motion planning is kind of compounding of actions like we talked about before, like we're doing with Durable. That gets a lot more tricky when the requirement of the user is like, I want to introduce 2 people via email sender, So but there's the same thing at play, is that application is compounding actions, and you need to be able to plan and see what are the consequences of the actions. How do they compound together to get to the user requirement? So going back to coherence, what you need that world model. You need, I think, some measure of like action compounding consequence. But I think another interesting thing that happens is context, meaning it. And here's a difference with robot motion planning. If my goal is to get somewhere, and I actuate my motors and I move, I can basically forget where I was for the most part, and my state just updates to where I am now.
Yeah.
But not all problems are like that. Sometimes where I was actually affects where I am now, and there's this context behind me that sort of reaches back, and I need to learn from it. I think what we're finding with decoherence with LLM agents is that the context grows. You maybe made some mistakes, you went some dead ends, and you need to know that. You need to be able to look back in the context and learn something from it.
Yeah.
As that context, I mean, imagine you have 10 years of context in your buffer. Like, where is the information that I need to bring into my current action so that I don't make the same mistake again, or I don't go wrong? I think that's what we're seeing, is that there is a horizon at which, and I'm not going to say retrieval from the context, but reasoning over the context breaks. Because it's not just retrieval. It's like, hey, I did these 5 actions over the context. They're spread out over years, but there's actually a nugget that I need to learn from that. And that's the useful thing I need now. So my hypothesis is that what's missing is an active learning component. That is basically, you can think about a compression. The simplest form is compressing that context into something that is then informing my current action continuously. If you twisted my arm, I would say that's probably a hypothesis generation active learning system that's looking at the past, forming hypotheses about the results of my actions and the information about the world, proving those out, and then compressing them, throwing away the junk, and then keeping that set. But I don't, I think it's wide open what that looks like. But I do think that's missing right now.
I completely agree. I mean, I think to give you an example that is probably more mundane, but I've seen this, is I use ChatGPT quite a lot in my daily life, especially on personal stuff. For like reading, I like history reading, and so I use ChatGPT to reason over chunks of books that I read about history and stuff like that. And I realized when OpenAI released the custom GPTs, like the ChatGPT assistants that you can build as an individual, I started using them very actively, but they only help me with the initial context. It's a way to seed let's call it context at the beginning. I actually don't get any benefit I get the same benefit as if I had a prompt, as an initial prompt copy pasted on a TXT file, and I just pasted it at the beginning of every prompt. And so something that I've noticed is, and I think a couple friends of mine made fun of me for this, is I have a couple of long-running threads with ChatGPT that I've been using for the last 2-3 months, because I need the context of everything I've done with that thread. And I actually looked into, I wanted to know if in ChatGPT you can copy paste, like you can duplicate a thread so that you can bifurcate it and start from 2 different conversations. You can't do this, by the way. You can copy paste an entire thread and just paste it on a new conversation. However, after 2-3 months, it starts tripping out, which is probably a informalism for it starts losing coherence. And it's that as soon as it gets trapped in a rabbit hole or in a dead end, it's unfortunately not learning from that dead end, but carrying it over as context to everything I ask in the future. And so it actually becomes this thing where every request is more expensive than the previous one, right? Because it's a chatbot and you're always sending the entire history. But you get to a point where you actually don't want to do that. One thing I started doing it is, as a means to hack the system, is going back to a previous message of mine, editing that message that actually deletes the entire succession of messages after that and starts over from that point. It's a pretty horrific access pattern. And I'm starting to wonder, like, yes, I wish there was an active learning system other than, I know ChatGPT released memory for individual users. It works okay. It's kind of freaky when it does that because you're just throwing in a little bit of a factoid about something regarding your family. Like my wife and I use it a lot, and it will say memory updated. And I was like, well, I didn't want you to add memory to anything. But I truly think you're completely right. There is a need for an active learning system. I think it remains to be seen what the shape or form is of that. Like, is it pure, like, I mean, I'm sure there is a very primitive version of this where you just store a bunch of statements or let's call it axioms of learning on a vectorized database, right? So you're just storing embeddings of these learnings, and then you allow the LLM to access these as tool calls as you ask questions. So it sort of learns, but that doesn't feel like, that feels, again, like a very token by token.
Yeah. And then you have to maintain the functions and whatnot. And it's funny that, like, I feel like your debugging process was funny because it reminded me of, like, do we need, like, git bisect for context? Like Windows, like, we need to be able to, like, trace back and find where that wrong statement was kind of, Nima, as you're saying, it's like every decision is, like, wrong from there. And just, like, being able to sort that, like, dissect that back, like, strip that context down and start anew. But yeah.
Yeah, it's interesting because I when I think about what it needs to learn, well, what it does today is you take that context, in context learning, then creates an abstraction that is tailored for whatever it is you're trying to do now. But if you want to compress that knowledge, learn something from it that is agnostic to what you're going to do next, because you're sort of doing this offline, then you're forming an abstraction that is not conditioned on what you're doing at that moment. It needs to be a kind of a more of a universal abstraction that can be used anywhere. And at least with deep learning, the only mechanism we know how to do that with is backprop. I mean, somewhere the model is creating these abstractions that are universal that can be applied to all these different ways. But in context learning is at least not doing it in a way that's accessible, that you can take that abstraction and store it somewhere. And if it is doing it, it's going to be very specific to the task at hand. So I think it is an open question of how do you form, let's say, continuous abstraction from the context that then you can use for any task, not just a specific task.
Do you think, I think that makes total sense. Do you think that there is a space, because we've been thinking a lot about this, and I mean, honestly, for our users, this is not just from feedback we've gotten from our customers, right? Like the feedback that we keep universally hearing from, especially enterprise, regarding agents is that there is no concept of learning, right? And you sort of have to stop the running of the LLM, give it additional context that is based on previous misdeeds,
right,
and then run it again.
Right.
And we've thought a lot about what is the expression of this knowledge for the context of our customers, because we enable a lot of in production data structuring and like processing workflows. And there's a couple things. One is obviously the basic of a vector database, storing a bunch of embeddings, hoping that those embeddings reflect learning in some fashion or gotchas, right? And you can, I'm sure you can have a tool call where you actually tell the LLM, if you run into these gotchas, please record them for future reference. But I wonder, is there an opportunity to create something that almost lives in the latent space while the LLM is actually in runtime, right? Because when I think about a human workflow, like a human executing a workflow, and we do this every day with Notion, right? There is if I am training a new employee at a company, there is a combination of manuals and memos and guidebooks that the team has created for knowledge sharing, and that's fairly common as you grow as a company. But there's also a level of semantics that is latent while they execute these new tasks. Like they keep them in mind, and it's almost like synthetic reasoning over the stored memory, if that makes sense.
Yeah.
I feel like I'm getting into a trap because now rather than anthropomorphizing LLMs, I am now LLMing humans in a way. But I don't know if you've seen anything of the sort, or if there's an opportunity at like creating a concept of memory that feels a little bit more organic for a stochastic process as opposed to these like tool calls.
Yeah. Well, I don't know how to do it in using the same continuous embedding spaces of LLMs. I can tell you what we've done at Durable, because we need this capability. We basically need to know, we can't from the onset know the consequence of every action. We're going to discover these. We're going to run, we're going to create some software. It's going to run. It's going to have some error or a result in something that is different to what we thought. And we need an update mechanism so we can update our world models. And the next time we pick that action, we understand the consequences, or we add additional side effects, or whatever it is we observe. So we've sort of, this is a fundamental part of what we need to do. The way we think about it is via hypothesis formation, meaning you have an action that you're taking, it has some consequences. Ideally, every time you take that action, your existing knowledge should be able to infer the consequences correctly. Mm-hmm. I should be able to say, hey, I did this action, with these inputs, I expected this, here's what I get. Now you don't get that, you get something else. The hypothesis formation is the process of taking that new input that you couldn't infer before and creating an update to the hypothesis of cause and effect, so that you can do this. And we actually don't do this in a continuous space, because I think to do it in a continuous space, you would have to have lots and lots of examples. You would have to isolate this hypothesis. None of these things are currently possible. Yeah. You can't isolate a hypothesis inside the network. You're basically batch training it, and it's training. Well, we're assuming that it's going to be focused on whatever it is that it infers that data, and it's going to update that. But it's very hard to say, here's one example, here's two example, update your internal model of the cause and effect. That's what we're doing. This is a neuro-symbolic learning technique where you're taking very few examples and you're inducing hypotheses. Then we can test that hypothesis based on our existing knowledge, world model knowledge, and also all of the jobs that we've done before. Like, okay, if we were to update this cause and effect, will it mess up any of the other plans that we did? Because if it does, then we have a problem. Like we the knowledge is incorrect. This is the only way I know how to do this.
It's probably the most human too, right? Because I think it's really interesting. Our engineering team, we've been talking with our team about how to formalize a little bit more our product development process, right? And right now we're a team of 6. And so far, we haven't needed it, right? You don't even need specs. That's a huge, you don't want to scale that into infinity, but like when you're 5, 6 people, there's enough, you can move fast enough without, let's call it product level specs. You should do engineering planning. You should do it. And so now that we're growing and the complexity of the product is growing and we have more customers, now we're like, no. What is a good product experiment framework to continue iterating and move fast? And one of the things we've been talking about with the team is hypothesis formation. And it's funny because I feel like this is very much regarding, at the end of the day, this process that you described at Durable is essentially an engineer running into issues and going back to the product manager and saying, we run into issues. I think we need to do a little bit of a 2.1 version of the user stories. Do you want to take a stab at iterating on this source of truth? And I feel like the way that I've always described it is, as a company, as a team, you always want to find the fastest, cheapest way to validate a hypothesis with enough conviction. And sometimes that means you can do a Figma, right? In the spectrum of like prototyping versus coding, you can go all the way from a PowerPoint or a Figma to a fully functional prototype that is based on code that you hope will scale and you won't have to break. And I think it's a very interesting process. It's a very human process. And I think that's what a lot of people don't understand when we talk about user stories. It's almost like a fact that today at a larger company, if you're building software, you don't use PRDs, you use user stories. I think a lot of people don't know why. I think they think, oh, they read a PRD from the 80s and they're like, oh, look at how IBM used to write functional requirements. It sounds like you're writing some sort of like manual for a fridge. And I think a lot of people think that user stories are just a better way to write functional requirements, when in reality, user stories were made so that you can write hypotheses. And that is the difference between iterative development and waterfall development, is that waterfall assumes everything is perfect, and then you hope it isn't by the time you release. And then iterative development is, you know, it won't be perfect, so you're writing it as a hypothesis. So it's all about hypothesis formation.
Right.
And I think as a knowledge storage and synthesis process, even for an LLM, could be super, super interesting. I mean, it makes total sense.
Yeah, and it's a little bit for us constrained to be this way too, because the data is so scarce. I mean, if you think about your runtime data as an agent, the data you have that you need to learn from, it's going to be single samples. It's going to be, I encountered this unique situation where my world model failed me, where I did something wrong. We went down a path that I wasn't expecting. That one example is what I need to learn from. I don't get to do that 10,000 times and then have this massive corpus, because it is by definition exception. You're in the long tail.
Yes.
So this mechanism of learning became pretty clear for us, that we need to be able to learn from small sample sizes, which is where you need to form hypotheses and then validate them explicitly. Storing the information, we have an embedded retrieval for this information. But the information itself is stored in an internal representation that is a mixture of code and natural language.
Makes sense.
It would be nice to backprop through that, so you could optimize that whole representation. I don't know how you would do it. I mean, I don't think I've not seen anyone backprop through explicit hypothesis formation from very few data points and creating the resulting abstractions.
And even if you could, you may create unnecessary complexity. And so it may actually, this goes back to, I've told this to Upal a few times, like, just because, regarding Codegen in general, just because you can generate perfectly valid code doesn't mean you should just paste it onto a repo and click run. Right, like there is a reason why there is a development life cycle, and a lot of the development life cycle is understanding, knowledge sharing amongst humans, communication. This is so awesome. I know we have a few minutes left. One thing that we wanted to ask you is, what are you most excited about in I mean, we're wrapping up 2024. 2025 is going to be probably just as crazy. I mean, I feel like every time I open my computer, there's something new that is happening.
Yeah.
What are you most excited about in 2025, specifically in AI for the industry where the three of us are?
I think there's now this realization that taking actions is a whole different game. There's probably going to be a lot of coherence-related activity, trying to make agents be coherent over longer time spans. I think that's really interesting. I suspect a lot of the problems that we've faced are going to be much more in the fore, because so much of it has been focused on pre-training capability, pre-training efficiency up to this point. Which is I think the dynamics of it are really different. The problems are really different. As for us, I'm really excited to be now in finally the position where we can roll this thing out. It just took a long time to build. I think we actually deployed it too early this last year. Learned a lot from it, but now getting to the point where I feel like we can actually deploy it with a select few customers, early customers. That's pretty excited about that too, and we're started to be able to use it internally as well, and that's a nice little milestone.
That's awesome.
But I'm sure next year is gonna be wild.
We're excited for you guys. I feel like, are you guys focusing on any particular verticals right now?
Yeah, we have looked at the phone automation space a little bit. We like that. There's we've looked at generating little validation programs for LLMs. People are interested in creating like basically programs that deterministically validate whether a particular prompt works or not.
Oh, very interesting.
Yeah, we haven't, I would say, we haven't really nailed a vertical and really committed to it. We've currently built the system such that we can point it to APIs, we can ingest those, we can build a world model around it.
Yeah.
But I think it does depend on who ends up being a really good fit for an early design partner, and then I think we'll rally around that. So we're just looking at a couple options right now.
And I think that's totally right. I think that was also our very beginning. It was like, well, let's just see where we feel the pull from. And based on that, then you get a feeling of the shape of the product, the texture of it, the axis pattern. Because one thing is the underlying functionals, and the other one, very different, is how users, what are the use cases, right? So an investor, I think, recently mentioned to us, like, companies don't buy horizontal software, they buy use cases.
Yes. Yeah.
And so for us, we made a strong decision to stay a horizontal platform. But being a horizontal platform is something you have to earn, because while you get to tell people, oh, my TAM is huge, I have trillions in TAM because we can do anything, that's not true. That's just not true. And so you got to earn it by building texture that makes sense for all of these verticals, and generalize and templatize the texture, and to a point where people are like, got it, I know I can succeed.
Yeah. I mean, it's good to have a flywheel that you can credibly say will spin you horizontally, but you're going to start at some point very vertical. Unless you're OpenAI, and then you just go for horizontal from the beginning. I guess after 7 years, but still.
Yeah. Well, thank you so much, Nima. This was so awesome. I think it's very rare to get to talk to someone that both has been working on this space deeply for years, but also has a very different take than most companies out there have on Codegen, specifically in generation of compute. So thank you so much for joining us. And I feel like this was such an awesome conversation.
Yeah, thank you for having me, Antonio. Upal, this was super fun. I really enjoyed it.